Where Boundary Scan really shines is when you drop a device into X-Test mode so you can manually control every scan-enabled pin on the device. In Universal Scan, that's easy. We just right-click on the device, select X-Test, and say OK. A warning pops up saying, are you sure you want to do this? Because remember, you're going to now have control over every pin in the device regardless of what its design intent was. In this case, we know we're OK, so let's click on OK. Remember, in this mode, you have severed the connection between the internal logic and the pins on the device. This is best seen by looking at the logic behind the pin. So I'm going to select pin 1 here, right-click on it, and if you look at the diagram now, we have the blue box representing the metal pin on the part, this black thick line is the package boundary, and the blob of yellow logic inside. You can see that we can still monitor what the pin is doing via the input cell, and we can still see what the internal logic is trying to do to the output buffer in the tri-state, but now we control the output buffer and we control the tri-state. Universal Scan will also allow you to drive the input, but in most devices that isn't connected. That's reserved for another mode. The key thing to remember is with Universal Scan, you can connect a switch to any of these 3 nodes. So now I can connect a virtual switch to the output buffer and to the tri-state and have total control over that pin on that device. To connect a switch to pin 27 on the Xilinx, you just select it from the toolbar. These are my switches up here on the toolbar. I'm going to select a toggle switch. Let's give it a name. I think I said pin 27. On the first device in the chain, that's fine. I can select any device I want. Pin 27, I'll just type it in. Color it red. I can invert it. I can auto toggle it. I can choose which switch type. And most importantly, I determine what I want to drive. In this case, I want to drive the output buffer. Here I'll say OK, and that places a switch right at the output buffer of that part. In addition, I want a switch controlling the tri-state. I'll say try 27 on device 1, pin 27, same color, controlling the tri-state signal now, and I'll put that side by side. So now if I go look at that pin, where's pin 27? This is pin 27 right here. Let's mark that pin so we can keep an eye on it. Got a little box around it. So now if I drive the output buffer, the pin does not respond. Why? Because the output enable isn't enabled. If I now enable the pin, then sure enough, if I watch the pin as I toggle this, you can see it's responding. I now have total control over every pin on this device. This particular pin is connected to pin 40 over here on the lattice. So let's hook up an LED to the input buffer so we can do a little continuity test. I simply grab an LED, say pin 40 or give it any other name I want. Let's hook this up to the lattice device, the second device in the chain, pin 40. Color it red, look at the input cell, say OK. Set that over here, and now simply by punching the output buffer on the Xilinx, I can see if I have continuity all the way over to the lattice. Very quick, very simple. The other switches available are the momentary switch. It's the exact same thing as a toggle switch, but only stays down as long as you hold the mouse on it. A dip switch, so you can control 8 things very quickly. A hexadecimal thumbwheel switch, a decimal thumbwheel switch, and a 7-segment thumbwheel switch. For example, I can take the 7-segment thumbwheel switch, tell it that I want all of the segments connected to the first device in the chain, use the pins that are driving the 7-segment on the board, and then I want to drive the output buffer of those pins. In addition, I want to invert the applied value because this particular device is a common anode. If I take this thumbwheel up here now and I drive that thumbwheel, I can now control the pins on the device via the thumbwheel switch. If I actually want to see the results, I can do that with my 7-segment LED, as we did in the previous example. It only takes a second to fill it in, so let's just do it. And I want to monitor the input, invert it, say OK. And sure enough, from X-Test, I now have total control over every pin on this part. Now remember, if I see the pins responding correctly, but I don't see the LED on the board responding, well, I know I have a hardware problem. And the beauty of this is I haven't even had to touch the hardware. All I needed was my laptop and a download cable. That's the beauty of Boundary Scan. The key points in this video clip are that Universal Scan makes it easy to control the pins on a device by using virtual switches. And you can connect those virtual switches to any of the 3 points in the I/O buffer. although you'll usually only want to control the output in the tri-state signals. That third input signal is reserved for a special mode in boundary scan called in-test.